Section 250.104 of the National Electrical Code addresses bonding of metal water piping. The intent of Section 250.104 is to create a low-impedance path for fault currents to return to the electrical source, minimizing the potential for electrical shock. When a dwelling utilizes all-plastic water piping, the metal faucet fittings can introduce an isolated conductive path. Even short metal stubs extending from faucets, such as those at sinks, bathtubs, and hose bibs, can carry fault current. These isolated metal parts need to be bonded to the grounding system. Bonding, in this context, means creating a reliable electrical connection to the building's grounding system. This ensures that if a fault occurs, the current has a safe path to flow back to the source, tripping a circuit breaker or ground fault circuit interrupter and de-energizing the circuit. Without bonding, a fault could energize the metal faucet, creating a shock hazard. The code technically requires bonding to each faucet where metal stubs are present and the water piping is entirely plastic. This requirement addresses a potential safety issue. There are several methods for bonding these faucets. One common approach involves using a bonding jumper. Firstly, a bonding jumper, typically a copper wire of appropriate gauge, is connected to the metallic cold water pipe, if available, before the plastic piping begins. Secondly, this bonding jumper is then run to each individual faucet. Thirdly, the jumper is securely connected to a metallic part of the faucet, often using a grounding screw or clamp. Another method employs a bonding bushing. Firstly, a bonding bushing is installed on the cold water pipe where the metal pipe transitions to plastic. Secondly, a bonding conductor is connected to the bonding bushing. Thirdly, this conductor is then routed to each faucet, again attaching it securely to a metallic part of the faucet. The size of the bonding jumper is determined by NEC Table 250.102 code and is based on the size of the service entrance conductors or the equivalent size of the supply conductors. The bonding conductor must be sized appropriately to safely carry the available fault current. Proper installation is crucial. Connections must be tight and corrosion resistant. The bonding jumper must be protected from physical damage. It's also important to note the exception if any portion of the water piping system is metallic. If the dwelling incorporates any metal water piping, either within the building or underground, then bonding each individual faucet might not be required. The metal water piping itself acts as a grounding electrode and provides a continuous path back to the service. In this case, the focus shifts to ensuring the main water pipe is adequately bonded near its point of entry into the building, according to NEC 250.104a. This exception recognizes that the continuous metallic piping system inherently provides a grounding path. However, if sections of metal pipe are isolated by plastic fittings or couplings, those isolated sections must still be bonded. Always consult with a qualified electrical inspector to ensure compliance with local codes and regulations. Local interpretations of the NEC can vary, and the inspector can provide specific guidance for your situation. In summary, bonding faucets in dwellings with all plastic water piping is a crucial safety measure. It ensures a lower impedance path for fault currents, reducing the risk of electrical shock. Proper installation of bonding jumpers or bushings is essential for effective grounding. Always refer to the National Electrical Code and local regulations for specific requirements. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you are not comfortable performing the work yourself. Understanding the principles behind bonding and grounding is essential for electrical safety. Grounding and bonding are distinct but related concepts. Grounding connects the electrical system to the earth, providing a reference point for voltage. Bonding connects metallic parts together to create a low impedance path for fault currents. Both grounding and bonding work together to protect people and equipment from electrical shock and fire hazards. The National Electrical Code provides comprehensive requirements for grounding and bonding. Adhering to these requirements is essential for ensuring electrical safety. Regularly inspect your electrical system to identify any potential hazards. Look for loose connections, damaged wiring, and signs of corrosion. If you notice any problems, contact a qualified electrician to make repairs. Electrical safety is everyone's responsibility. By understanding the basics of grounding and bonding, and by taking steps to maintain your electrical system, you can help protect yourself and your family from electrical hazards. The metal faucet extensions are often connected to the plastic water lines with a threaded connection. Even though the connection may seem tight, it is not considered a reliable electrical connection for grounding purposes. This is why a separate bonding jumper is required. The bonding jumper provides a dedicated, low-impedance path for fault current to flow. When selecting a bonding jumper, be sure to choose a wire size that is appropriate for this circuit. The NEC provides tables that specify the minimum size of bonding jumpers based on the size of the circuit conductors. It is also important to use a listed connector to attach the bonding jumper to the faucet and the grounding electrode. Listed connectors are designed to provide a reliable electrical connection and are tested to meet safety standards. In addition to bonding the faucets, it is also important to ensure that the metal enclosure of any electrical equipment is properly bonded. This includes electrical panels, junction boxes, and lighting fixtures. Bonding the metal enclosures helps to prevent them from becoming energized in the event of a fault. The NEC requires that all metal enclosures be bonded to the grounding system. This can be accomplished by using a bonding jumper to connect the enclosure to the grounding electrode conductor. When installing a bonding jumper, be sure to remove any paint or corrosion from the surfaces to ensure a good electrical connection. It is also important to tighten the connection securely. A loose connection can create a high resistance path for fault current, which can lead to overheating and even fire. Ground fault circuit interrupters, or GFCIs, are another important safety device that can help to protect people from electrical shock. GFCIs are designed to detect ground faults and quickly interrupt the circuit, preventing a dangerous shock. The NEC requires GFCIs in many locations, including bathrooms, kitchens, and outdoor receptacles. It is important to test GFCIs regularly to ensure that they are working properly. To test a GFCI, simply press the test button on the device. The GFCI should trip and interrupt the circuit. If the GFCI does not trip, it should be replaced immediately. Arc fault circuit interrupters, or FSIs, are another type of circuit breaker that can help to prevent electrical fires. FSIs are designed to detect arc faults, which are a common cause of electrical fires. The NEC requires FSIs in many locations, including bedrooms and living rooms. It is important to understand the difference between GFCIs and FSIs. GFCIs protect people from electrical shock, while FSIs protect against electrical fires. Both GFCIs and FSIs are important safety devices that can help to protect your home and family. Regularly inspect your electrical system for any signs of damage or wear. Look for frayed wires, cracked insulation, and loose connections. If you notice any problems, contact a qualified electrician to make repairs. Never attempt to repair electrical equipment yourself unless you are a qualified electrician. Electricity can be dangerous, and it is always best to leave electrical work to the professionals. Be sure to follow all electrical safety precautions when working around electricity. Always turn off the power before working on any electrical equipment. Use insulated tools and wear rubber gloves. Never work in wet conditions. By following these safety precautions, you can help to prevent electrical accidents. Electrical safety is a serious matter. By taking the time to learn about electrical safety and by following all safety precautions, you can help to protect yourself and your family from electrical hazards. Remember, when in doubt, always consult with a qualified electrician.